Okay. 2.3 signal and propagation. First kita tengok signal dulu. Frequency is the relationship of the signal to time, and the frequency of wave is the number of cycle it completes in 1 second. Electromagnetic signal are oscillating waveform. There is the fluctuate continuously and predictably above and below a mean energy level. So time sama dengan A sin 2 pi feet plus O ni apa? Uh, Alah, nama apa ni? Theta kan? Theta. Okay, signal and propagation in wireless network. The signal has no wire to determine the direction propagation, whereas signal in wired networks only travel along the wire. Signal propagation is the movement of radio wave from a transmitter to a receiver. Wireless transmission propagate in three modes: ground wave propagation, sky wave propagation, and line of sight propagation. Ada tiga. Three modes. So, ground wave propagation follow the contour of the Earth. So, sky wave propagation use reflection by both Earth and ionosphere. So, line of sight propagation require the transmitting and receiving antenna to be within the line of sight of each other. Depending upon the frequency of the underlying signal, the particular mode of propagation is followed. So ground waves, ada gambar senang sikit tengok kan. Ground wave propagation follow the contour of the earth. Contoh dia buat bumi ni bulat kan, tapi tak adalah macam ni kan. Dia punya bulat tu tak nampak sangat bulat kan. Ini dah mana kalau ini kalau betul di scale earth ni besar gila kan. Tower antena dia kan. Kan? Dia nak tunjuk kata sebenarnya walaupun transmission tu berlaku macam direct, sebenarnya dia adalah dalam bentuk graviti juga, dalam bentuk apa nama sfera kan. Patutnya buat je lah direct, tak payahlah buat sedikit bulat macam ni kan. Buat terus panjang pun boleh. Kita faham lah kan daripada antena tu antena. So, daripada ground wave propagation. The ground wave of surface wave is guided along the surface on the earth. Guided tadi wired kan. Ground wave propagation below 2 MHz. Okay, ionosphere kita pakai sky wave propagation. Okay, sebab dia akan dia hantar ke atas, tapi sebenarnya dia tidak pergi keluar daripada kita punya atmosfer kita. Atmosfera. Kan? Lagu atmosfera, lagu apa? Ingatlah. Asyiteru ke? Atmosfera tu. Itu lagu je punah kan. Okay. So, kalau terkeluar kita panggil penetrate wave. Kalau dipatah balik, kita panggil reflect kan. Okay, kita panggil reflect. Kita panggil sky wave. Sky wave propagation. Ya, kalau ke atas juga tapi dia tidak pergi ke nama apa tu? Satellite kan. Okay. Beza sikit kan direct. Kenapa dia tak nak buat macam tadi? Rupanya dia ada term dia panggil line of sight propagation require the transmitting and receiving antenna to be within the line of sight of each other ataupun loss kan, line of sight. Rupanya ada jawapan dia kenapa dia tak. Dia buat juga bentuk sfera kan, dia ikut keliling bumi. Rupanya kalau direct dia panggil signal propagation line of sight. Okay, so untuk speed pula. Propagation speed. The propagation speed of electromagnetic signal depends on the medium and on the frequency of the signal. For example, in a vacuum, light is propagated with a speed of 3 times 806 meter per second. Kan? So we can measure the distance of signal travel. Bukan ni. Alah, meter bukan 1008. Ni 1008 bukan 108 meter per second. 1008. 1008. 10 kilometer. 10 10 berapa? 10 Masa ni lah nak sembang pun kan. Kelah-kelah kan. Sabar lu. Dah habis lah 5 minit ni. 10 lepas kilo mega kan. Tapi kita tak panggil pun megameter kan. Pelik lah kan. Kilo, mega, giga tak ada. Tak panggil. Kan. Okay. Kalau pen kita panggil kilometriko kan. Ini kilometer ni 10/8 ni. Yang lebih sikit daripada 10/6. Kalau 10/9 senang. Kita tahu giga kan. Ataupun bilion kan. Ni dalam 100 ribu. 100 juta lah. 100 juta. 10/3 1000. 10/6 juta. 10/8 100 juta. 10/9 1 bilion. Ni betul kan lah? Saya boleh betulkan. Saya pun boleh betulkan. Mana? Salah. Mana sini tak ada. Superscript kan? Nyebut dah. Save. Kalau baca slide je tak faham kan. Kenapa 3 kali 108? Kali je lah 300. 8 kali 3, 24. 3 kali 3 kan. We can measure the distance a signal travel through a medium in 1 second. Propagation time equal to distance propagation speed. The time required for signal to travel from one point of the transmission medium to another is propagation time. So tak sempat lah kita. Wave propagation, electromagnetic wave can move through a perfect vacuum or pass through material of different mediums. The way in which the RF wave move, known as the wave propagation, can vary drastically depending on the material in the signal path. For example, drywall will have a much different effect on RF signal than metal or concrete. What happened to an RF signal between two locations is a direct result of how the signal propagates. So when we use the term propagate, try to invention of RF signal bending or spreading as it travel farther away from the antenna. So as a WLAN engineer, you should understand RF propagation behavior for making sure that access points are deployed in the proper location, for making sure the proper type of antenna is chosen, and for monitoring the performance of wireless network. Go, habis. Right, so yang 4 dan 5 saya akan upload ke YouFuture. Boleh ya? Itulah sebabnya kita tak boleh nak habiskan dalam satu seminar kan. Alright, faham kan? Okay, semua kena dalam YouFuture nanti. So Alhamdulillah kita habis juga 3 subchapter kan. Any question?